Now that we've looked at how to find an angle between two vectors, it's time to look at some special angles between two vectors. Two of those are orthogonal and parallel, and you may be wondering, what the heck is orthogonal? Well, look at the root word, ortho. When I see ortho, I think of the orthodontist, someone who makes your teeth straight or perpendicular to your jaw, or as much as possible. So ortho or orthogonal simply means straight, it means perpendicular. And then parallel is the parallel that you've known for a long time. So you will not find this slide on your handout, but I wanted to give you a visual of what's going on with these and why these work, kind of relate it back to algebra. So I'm going to name some of these little vectors here. I'm going to name this vector u, this is vector v, and this is vector w. Now let's talk about slopes. The slope for u is 2/3, up 2 over 3. The slope for vector v is down 3 and right 2. And the slope for w is up 2 and over 3 in general. So you can see right away that vectors u and w are parallel. They have the same slopes. And you can also see that these guys are opposite in sign, and they are also reciprocals. And when that happens, then we have perpendicular lines. So u and v are perpendicular. Now, what happens with dot products? How does this all relate to dot products? Well, if we take u dotted with w, we're going to get -3 times 3 plus -2 times 2. So we get -9 plus -4. We get -13. Doesn't really seem like anything special. But watch what happens when we take u dotted with v, the two perpendicular ones. So we have 3 times 2 plus 2 times -3. We have 6 plus -6, and we get 0. That is unique to orthogonal vectors. When you take their dot product, you get 0. And that's where we end up here on the next piece. The definition of orthogonal vectors, if you can take their dot product and get 0, then those two vectors are orthogonal. So take a minute to write down this in your notes. Now let's take a look and determine whether u and v are orthogonal, parallel, or neither one. Now you've seen one that was neither in the example right before this on the last video. Let's take a look. So we have the magnitude of u. We've got 8 squared, so that's 64, plus 4 squared, that's 16. So we end up with the magnitude being the square root of 80. The magnitude of the vector v is square root of 4 plus 1, so it's the square root of 5. Now the other thing that we used in our formula before with the cosine of theta being the dot product over the magnitudes multiplied together was the dot product, and probably should have started off with that right away. Check the dot product, because if we do get that u times v is 0, u dot v is 0, then we don't have to do anything else. Let's just double check. So we have u dot v, that's 8 times -2 plus 4 times -1, -16 minus 4, that's -20. So we're not quite sure yet if it's parallel or neither one, but I can guarantee that it's not orthogonal. That is off of our list. Their dot product doesn't equal 0. So let's find out what the angle is, because we haven't really looked at the parallel part yet. Cosine of theta equals the dot product, -20, over the product of the magnitudes. So that's the square root of 80 times the square root of 5. So that's -20. And that's the square root of 400, which is, well, the square root of 400 is 20. So I have -20 over 20. That's -1. So we'll solve this little equation. The cosine of theta equals -1. That happens when theta is 180 degrees. That seems like a special angle. So let's take a look at these slopes. We're going to take a look at our vertical component for u compared to our horizontal, rise over run. So the slopes that I'm looking at here, for u, the slope is going to be 4 over 8. For v, the slope is -1 over -2 from up here. And hey, those both reduce to 1/2. They have the same slopes, and the angle between them is 180 degrees. They form a straight line, so to speak. So here's a major clue about parallel. If you get down to the cosine being -1, they're going to be parallel to each other. So let's recap. When do you have what? How can I tell if two vectors are orthogonal, parallel, or neither one? Well, they're going to be orthogonal if the dot product of the two vectors is 0. No questions asked. Check it out. If it's 0, you're done. They're orthogonal. Now, parallel, you're going to end up with the cosine of theta being -1, which implies 180 degrees apart. Another thing you can do just to double check if you don't end up seeing that somehow is that you can check the slopes. So basically you'd be taking and comparing v1 over u1, the vertical component and the horizontal component of one vector, and compare it to the slope of the other one. And if they are indeed equal, then they will be parallel. And of course, if you've already checked for the dot product being 0, and you've checked for these being parallel, the only other option is for them to be neither one. So that wraps up lesson 6.2.